Hey guys, welcome back to Science. Ms. Higgins here. In our last introduction lesson, I had asked you to read a few pages of the book called Patterns in Communication. In that, we learned that when a dolphin makes a sound, that sound travels as a sound wave. And we know that waves carry information. So remember, we're trying to figure out how a sound can get from a mother dolphin to her calf. So today we're going to study all about how waves travel. Our teaching point is that scientists compare and contrast wave patterns by observing slinkies, ropes, and our sim. So we're going to watch two different kinds of waves, one with a rope and one with the slinky. And as we observe, I want you to think, how are they similar and how are they different? So let's look at the slinky first. And let's take a look at the rope. Okay, so take a second to think, how were these waves similar and how were they different? Well, in the slinky, I noticed that that's more like wave A. The slinky was moving back and forth. So that's our first wave pattern, is back and forth. And in the rope, that was different. It was moving up and down. So that's a second wave pattern that we observed. I noticed in both waves, the source was someone's hand. So the energy was coming from someone's hand. When the hand moved, so did the slinky and so did the rope. So it transferred the energy from the source into the object. So we just learned two different wave patterns. One was back and forth, the other was up and down. An important word that we'll need to know is source, and that's the place where something comes from. So in these two examples, we can say that the hand was the source. That's where the energy was coming from, and it was transferred then into the wave. Now, there are many different types of energy. We have kinetic, which is motion energy that we just studied. We have light energy, thermal energy, chemical energy. But now we just want to focus on sound energy and sound waves specifically, since that's going to help us figure out how the sound travels between the dolphins. So we're going to open up our sim and look at sound waves from instruments. And we're going to think, how is the wave pattern that we're seeing in the sim similar or different to the slinky or the rope? So we have instruments here. We're going to listen to a sound and we'll see what happens to all of these dots or particles. Let's listen to a double bass first. Okay, cool. It looks like the source is over here and it's pushing, the energy is pushing the particles across the screen. Let's see how a cello might be different. In this one, the waves are moving a little faster. The double bass was kind of slow motion. And then the cello moved faster. Let's see how a viola might be different. And a violin. We have a flute. We have a drum. And finally, a piano. Okay, so where did this sound come from? We identified the source on the right-hand side of the screen. So the source was over here. This is where the wave started. What pattern did we see? Well, it kind of looked like the slinky. I would say that it's similar to the wave pattern in the slinky because it was moving back and forth. What do you think was happening? Well, it looked like each dot or particle was kind of bumping into the next one, and it created kind of a chain reaction that pushed everything across the screen. And what happened to the moving dots? I think they were bumping into each other. So this is a zoomed out image of what those sound waves look like coming from the instrument. And what we were looking at in the sim is a very, very zoomed in portion of one of the sound waves. And that's when we see those particles or those dots. So sound, we know, is a type of energy. That energy is what is traveling. Now we need to figure out which way is the energy traveling. Well, in all three examples that we've looked at, the energy travels away from the source. Here, the sound waves travel away from the instrument. In the slinky, the waves travel away from the hand. And again, in the rope, the waves travel away from the hand. So now we know that waves travel away from the source. We talked about this a little bit, but the wave pattern that we saw in the sound wave in our sim was more like the slinky because the waves were traveling back and forth. The rope, on the other hand, its wave pattern was up and down. So we could say sound waves are similar to a slinky. For today, you guys are going to read this book called Warning, Tsunami, and you're going to be looking at yet another type of wave. And as you're reading, I want you to think, how is that similar or different to the wave patterns we just looked at in the slinky, the rope, and the sim? Then you'll jot a few questions on the Google Doc. One is, what is the wave pattern of a tsunami wave? Remember, our options are up and down or back and forth. And what is its source? Are tsunami waves similar or different than the rope waves? Why or why not? And finally, you're going to read that the water itself is hardly even moving in a tsunami. So what do you think is traveling as a tsunami wave moves across the ocean? When you guys are finished, don't forget to click Turn In. Good luck, happy working, and I'll see you next time.